Hi everyone. I'm here to talk about AI-driven development in Go. In the past, I talked about Go with DevOps and machine learning and even mobile. And last year, I gave a workshop here at GopherCon about building an end-to-end machine learning platform with Go. And in the previous year, we talked about the importance of beginners in the Go community. If you'll try really hard, you will find a regular Go talk of mine, but that's not our plan for today. So my name is Natalie, and this is a picture that I took in the last vacation that I got to do 2 years ago. And it was a great decision because it was super nice and the memories keep me going through the last 2 years. Another good decision that I made was take a job that required me to use Go back in 2014. A recent decision that I took, and I hope that will turn out to be good, is to dive into the world of AI engines. And if you want to hear more about decisions and thoughts and so on, join me in the Go Time podcast or in the Berlin user group of Go or at GopherCon Europe. Some other hats that I wear, in addition to my job as a lead developer advocate at Aerospike, is being a Google developer expert for Go, an OpenAI developer ambassador, and the organizer of all sorts of developer events. Our plan for today is to talk a little bit about the history of AI, then about AI-generated code and Go, and what does this mean for us as Gophers. Let's hop right into the history of artificial intelligence. So, classical philosophers like René Descartes and Galileo Galilei regarded thought, taste, odors, and colors as symbolic representations, and perception as an internal process. Then, in the summer of 1956, a group of researchers gathered together for the Dartmouth Summer Research Project on the topic of artificial intelligence. And this is considered to be the birth of AI as a research field. In the following years, access to digital computers became possible, and scientists instinctively recognized that a machine that could manipulate numbers could probably manipulate symbols as well. And as we said, manipulating symbols can be the essence of the human thought. And in the following years, indeed, computers were solving algebra problems, proving theorems in geometry, and were even learning to speak English. And researchers were optimistic, and they predicted that a fully intelligent machine is just a few years away. And government agencies like DARPA were pouring money into the field of AI. But in the 70s, those researchers and their optimism proved to be a little bit too optimistic for the difficulty of the problems. In addition, public criticism about artificial intelligence went up and the government funding stopped. This is called the first AI winter. In the 80s, AI was proven useful again, this time used as narrow AI, so for a specific domain. And specifically, this means AI-driven programs that were called expert systems. They were implemented in the different companies, and they were answering questions and solving problems using their internal knowledge base, and this was saving the industry a lot of money. In addition, Japan launched the fifth generation computer, which is a sort of a natural language processing machine, and following them, so did the UK and the US. Back came the AI funding. Progress in the field of neural networks and semiconductors enabled the development of practical artificial neural network technology. The industry was booming again. But the second AI winter came in the end of the 80s, specifically in 1987. Apple and IBM's desktops became more powerful than the expensive, dedicated AI hardware. This led to the collapse of the industry of the chips that are designed specifically for AI. The expert systems became too expensive to maintain, and DARPA once again stopped the funding. Then, in the 90s, the computational power was strong enough and cheap enough. AI was used to solve specific rather than general problems, and AI researchers began to develop and use sophisticated mathematical tools more than they ever had in the past. Algorithms developed by AI researchers were used in the industry, and in 1997, Deep Blue, the computer, beat Garry Kasparov in a chess game. And today, we are again in the era of the artificial general intelligence. And what's different is that the industry problems keep being solved by AI. This time, we also have big data, so a lot of data in each company. There is cheap and fast computers, and the ML techniques that are in place are more advanced though. The different industries have a lot more data about their users, and they increasingly use AI for their business logic. Now let's talk a little bit about the history of AI models. So in 2010, IBM DeepMind was founded. And in 2014, they joined forces with Google to accelerate their work while continuing to set their own research agenda. Some of the big achievements was to manage Google's data center energy consumption and AlphaFold, a system which accurately predicts the shapes of proteins. In 2015, OpenAI was founded as an AI research and deployment company with a mission to ensure that artificial general intelligence benefits all of humanity. And in 2017, Google AI was founded as a division of Google with a mission to conduct research that advances the state-of-the-art work in the field, applying AI to products and to new domains. Basically, develop tools to ensure that everyone can use and access AI. In 2018, GPT-1 was released. That stands for Generative Pre-trained Transformer, and this is a language model that uses deep learning to produce human-like text. Until now, most of the natural language processing models were trained specifically on a particular task. GPT-1, trained on 117 million parameters, performed better than most of the supervised models that were trained to solve a specific task. And not just that, it needed very few to no examples to get the context and still outperform the models that were trained to solve a specific task. Next, in the following year, came GPT-2, which is trained on 1.5 billion parameters. And in June 2020, GPT-3 was released. This model was trained on 175 billion parameters. You see the hop between each version of the model. That's 2 orders of magnitude. And of course, GPT-3 has a great zero-shot or few-shot learning performance. So where is AI today? Well, let's think quickly on what does today mean. Are we all aware that 2050 is closer than 1990? Okay, so let's minimize everything and focus on the last 2 years. We said that last year GPT-3 was released with 175 billion parameters, and this year Switch Transformer by Google Brain was open sourced. This model scales up to 1.6 trillion parameters. But the model release does not mean you can just go ahead and use it. You do need some hardware. In addition, Wudao 2.0 was released by the Beijing Academy of Artificial Intelligence. Wudao 2.0 is 10 times larger than OpenAI's GPT-3, which is trained on 175 billion parameters. It also has 150 billion parameters more than Google's Switch Transformer. But I don't know anyone who uses it. Looks like they have 12 partners at the moment in the forums of apps that are using this tool. And the most recent tool that was released is the Megatron Turing by the collaboration of NVIDIA with Microsoft, back to the scale of hundreds of billions. Now, here's a nice visual that I got from NVIDIA's developer blog. And here is a Reddit post that nicely puts everything in proportions. Apparently, we jumped from the mole rat brain to the octopus brain. I took the liberty of adding Google's Switch Transformer and Beijing's Academy of Artificial Intelligence Wudao 2.0. Anyone recognizing a hockey stick? For fun, let's add one more number. GPT-4 with 100 trillion parameters. While it has no official release date, the development of it is already in progress. Now, if you ask yourself, how does that compare to a brain size? The cerebral cortex is the outer layer of the largest part of the human brain. Only us mammals have it, and it's in charge of things like attention, perception, awareness, thought, memory, language, and consciousness. Wait, what? GPT-4 has the same number of parameters as our brain? That's pretty mind-blowing. Especially given that from all the models that we talked about, OpenAI's GPTs are the ones that are publicly available. Okay, enough nerding out about AI models and numbers. Let's talk how it's relevant for us. The introduction of AI engines introduced a new type of engineering, prompt engineering. Let's see some examples. We will do several demos, and you will probably recognize the different tasks that we'll see here from your everyday developer lives. And let's start with getting acquainted with what we see here, this interface. So the playground is the way you interact with the GPT-3 models, and you can start with choosing an engine. The OpenAI API is powered by a family of models with different capabilities. There is the base series that can understand natural language. Then there is the instruct series that is like the base one, but is better with following instructions. And there is codex that is specializing in translating language to code. So for this example, I'm going to go with the Da Vinci codex. And the parameters that you see here, this one is for creativity. This is for how long the response is. And stop sequence is when do I ask the AI to the engine response to truncate. There are several other parameters, and we can look at that at some other time. The first example is adding a unit test. So the input that I am providing is a part of a library, and this is all the context that the machine has. So it's a snippet of code that begins with package main, and it ends here. And there's also this, which you as a human can parse that this is where the code ends and the instruction begins. But this is all the context that we have given. Now let's click generate and see what happens. Lo and behold, it followed the instructions correctly. So it generated a unit test. It used a function from the right library. And it used the correct syntax, and it also used the correct formatting without getting any context other than what you see here. We will do several demos, and you will probably recognize the different tasks that we'll see here from your everyday developer lives. Next, I will use the AI to help me understand a new code base a little bit better. Let's say that I'm looking at this examples file for the Go client of Prometheus for the first time. I can go and read everything and read the comments and kind of make sense of it, or I can copy that and ask it to explain what do I see here. So the instruction that I'm providing is explain in detail this Go function, and then I'm just pasting a function. And look at that. It explains what it does, and it does explain in detail because this is what I asked. And you can always go back and read a little bit in depth once you have the bigger image, because this is what you got from the previous screen. Let's increase the complexity level and do some bash. So I have a file which I downloaded from Kaggle called spotify.csv, and it has a list of songs that were recently played. It's 4 columns: the user ID, the artist name, the track name, the playlist name. And I can see this is comma separated. So let's say I'm looking for some recommendations of new music to hear. So I can ask it to filter by the playlist name. And because I'm looking for songs for my work playlist, I'm going to search for words like deep focus or some combination of them. And then I want it to print in the specific format of first the playlist name, then the artist name, that's the second column, and then the track name, that's the third column. And I'm only asking for 12 rows, that's enough for me. Bash signature, and I'm starting with awk. Now you see that I already gave you more context than I gave to the computer, and it successfully gave me a command. Let's see if it works. I'm just going to copy paste that. And I have 12 songs. This is printed in the order that I asked it to print. First the playlist, then the artist name, then the song name. And I can see that the playlists were filtered by the word deep, so that is there. And it's not exactly what I had in mind when I was looking for deep focus, but as it happens many times when programming, prompt engineering is not different here, that it did what I asked it to do, not necessarily what I had in mind. The last example would be building a website. So I am asking the following: build my website. So the landing page will have this title, and then I want a button that would email me this email. This is not my email. Please don't use that for contacting me. And I want this specific cat image, and I'm giving a slightly vague instruction that add a list titled resources with 5 websites of online courses like Coursera. Let's see how well does it perform. So it generated this, and I'm just going to copy paste that into an online IDE. Specifically, I'm trying here with Replit, and I already have a new JavaScript project set up. I'm just copy pasting this into the HTML file and running it. And look at that. This is a title that I asked. This is the email. You can see in the bottom left that it will mail to the right email that I asked. And this is the image that I asked it to insert. And here is a list of 5 websites of online courses. So it did exactly as I asked it. And some things I could have improved, maybe give it in the instruction of not just websites, but maybe the URL of the website, right? Because you can interpret, add a list of websites with either adding their names or adding the URLs. And this is a small example of what prompt engineering is. You do use English because this is a natural language model, but this is also a model that was trained on a specific subset of the internet. So it has a finite world of context. It does not have your English level skills, whether you're native or not like me. And you have to find the right language to speak with it. And it doesn't have to be English. The model supports different languages as well. Some languages better, some languages worse. Now let's talk about AI-generated code with Go. Codex supports multiple programming languages. Python is the one it performs the best in, but Go is high up this list. And when we're looking at a small code snippet, it's kind of hard to say if a human generated it or if machine generated it. And I'm not just talking about a hello world, I'm talking about a complex command. For example, here's a name of a client. Please use it correctly to utilize its functionality. Implement 1, 2, and 3. Now, as a developer, I can say that using a new library will take some time for me. I need to figure out how does it do things, how do I do things with it, see some examples, browse the docs, but not Codex. Codex just says, not a problem, and it goes ahead and imports a library that I mentioned, not even by the name, but it's importing the right one. And it goes ahead and imports the library that I mentioned, not by the exact name. Still, it knows exactly what to import. Then it imports the additional required libraries, and it writes the code correctly with these libraries. It does exactly all the steps that I asked it to do, and it even documents the code. All that, and the code is written the Go way. If I told you that I wrote this code, you would believe me. But this is not always the case, especially when we're talking about generating a lot of code. The reason for that is that code that is machine generated in large amounts can look like it's machine generated. And that can be a problem because it can land us in the uncanny valley of code. The uncanny valley is a concept that was identified by the robotics professor Masahiro Mori in 1970. This is the hypothesized relation between an object's degree of resemblance to a human being and the emotional response to the object. Basically, if we're looking at this graph, on the left there is a robot that looks very much like a robot and it does things that are more efficient for us, and we're okay about that. Then, if you go right on the graph and you see something like a humanoid robot, so it looks a bit more like a human, that's even cuter, so we like this a little more. And when it goes to this creepiness area, where it looks like a robot, but it also looks like a human, and you're not sure how you feel about that, this is the uncanny valley. And when you pass that, when it's so resembling to a human, you cannot tell anymore if this is a human or a robot, you're feeling wonderful about this again. And this is not applying only to robots, this is also how you feel about code. Luckily, the Go code that we all know and love is already auto-generated with GopherCon. So we're actually expecting it to be rather robotic. So even if a machine will generate it in large amounts, we will probably not get feeling uncomfortable about that. Some additional good things about Go is that there is one clear way of doing things. There's no chance to get things in different paradigms, which will make it unfitting with different snippets of the code. And with the inevitably increasing automation, you do find yourself that you have to read even more code just because more of it is auto-generated. So as we, the developers, need to parse things more quickly and we become this little compilers, we really get to benefit Go's simplicity because it provides readability and it's always the same everywhere. And GopherCon parses the code to a syntax tree and stores it instead of storing the source code. And because all Go code has a similar outputter, another machine can have easier time creating this output. Cool! What's next for Gophers? Don't put down your keyboard and leave just yet. Instead, hop on the early train and embrace the automation. What's there to embrace? Well, good thing you asked. There's a lot to embrace. I will be skipping the examples because I'm sure you saw so many of them online already. And if you want to see more, you can always find them online, even if you go to the GitHub Copilot page itself. So the very first thing you can do is to automate the boring and repetitive part. Things like writing tests for the different types or even generics. Check out the agenda for more talks about this topic. You can get inspired by what the computer is proposing for you to write when you write a comment, for example, and it auto-completes a code block. So if you're not sure what to write, you can have a good start. If you're not sure about what you started with, you can always ask it for more proposals or consider alternatives before getting to the part of the pull request review by your peers. You can automate comments. Now, this point easily deserves a whole talk, but instead I will settle for showing you some interest answers that I got when asking about this point on Twitter. People don't document enough, not a surprise, and this slows us all down, also not a surprise. But I am looking forward to how AI engines that specialize in code will help us solve this and be more productive. One more benefit for Gophers is that AI can help you understand any code base. Yes, Go code base is written the same practically everywhere, and that's great. What happens if you need to interface with some other team? Front-end, mobile SDKs, even some of the infrastructure content. You can use the AI to explain code to you. Now, you ask, what is my prediction? AI-generated code will change software as we know it. Backend, front-end, mobile, game development, QA. We saw that the languages that are dominant in these fields are already supported by codecs. Data engineering is an interesting point. I'm not sure. More than instructions are still needed, but the execution is getting increasingly more automated. We can summarize this point with saying that AI will change development as we know it. Another prediction is that code generation will become part of our development flow. In the same way that the IDE already makes your development faster by showing things like the function signature and other useful information, all the benefits of AI-driven development that we talked about will become part of your developer flow. Everything will keep getting more AI-driven. We said how already a lot more data is being collected and used for recommendations, personalization, and so on. And all fields will keep being more AI-driven or data-driven or ML-driven, call it how you will. I mean, have you heard of legal tech? AI won't skip any field. Okay, so everyone has a lot of data. The code that is processing it is getting augmented. What about how it runs? Sure, there are cloud solutions like the Azure OpenAI service, but as with any cloud solution, it's not always the right choice. So everyone has a lot of data, and the code that is processing it is already getting augmented. What about how it runs? Well, infrastructure and monitoring already have a lot of automation in place. This will sure not go away, but you cannot just ask a model to autocomplete configurations for you. What I can imagine happening is a more efficient set of default values based on your use case, but not something that is production level ready, at least not in the foreseeable future. It's like these codex examples that show us how an auto-generated SSH key is part of code that it autocompletes. Yes, it's in the right format. No, it's not usable. So here is where ML ops or AI ops come into play. This is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. If you attended my workshop here last year, where we built this AI/ML infrastructure end-to-end using Go, or watched a talk of mine on the topic, you probably remember this paper and specifically this diagram from it. See that black cube in the middle? This is the code for the machine learning model itself. It accounts for about 5% of the code of the system. The rest of the code is a supporting infrastructure. And it's an increasing point of interest. Although the name split between AI and ML migrates here as well, and looks like it depends where you come from. Sure, there are solutions to help with that, like the Azure OpenAI cloud, but as with cloud, it's not always the solution, and hey, someone needs to maintain that cloud too. Security is another interesting point, and my personal prediction is that it will be similar to how it went in chess. What happened in chess is that the computer not necessarily became smarter than us, it just became powerful enough to be able to try all the different combinations in a very short time. So the machine was strong enough, powerful enough, cheap enough, and fast enough to do all the things that we cannot do because our computational power in the brain is limited. And you cannot necessarily say that the computer is smarter than us in chess, but they do beat us in chess. And I think this will be similar in this field. Eventually, it will be able to just try more things faster. Maybe all that's left for hackers is just social engineering, but that's for another conference. So what can you do today? Apply for the access to the different AI engines. Join the waitlists. There is the Codex waitlist for OpenAI. There is the general waitlist for OpenAI, which gives you access to GPT-3. And you can also, if you didn't get yet the Copilot access on GitHub, you can also apply for that. And you can go to AI21 for accessing a model that is a natural language model, but not focused on computing. As I mentioned, the other models from this talk are not yet publicly available. Next time you're looking for something to hack on, build and deploy a basic end-to-end machine learning infrastructure. You can find talks that I gave about this, and it will give you an example of how does a bare bone infrastructure look like end-to-end. Once you have that done, you can always add a lot more different features and components on it. There are multiple tutorials online about this, and there's even a workshop this year by Daniel. Integrate automation in your flow. VS Code already has GitHub's Copilot. This will keep improving in its performance, and a lot more extensions will come. And be excellent to each other. Your fellow human developers will stick around for a while. And that's it. We talked today about a brief history of AI and the current state of things. We talked about AI-generated code in Go and how it's designed with automation in mind and how it benefits us. And we talked about what's next for us Gophers. TLDR, automate more. Thanks for coming to this talk. I hope this taught you something new. I hope this inspired you to try something new. And I hope that next year we get to meet in person. And I would love to hear about all the interesting things that you got to do with code and AI. Thank you.